Hello, Mukerem.
Okay.
How are you? Doing pretty well. So we are going to have the semi-final interview.
Okay.
I hope you're ready.
Yes.
Let me just start the recording for this
Okay.
meeting.
Okay.
And we're going to start with introduction.
Okay.
All right. So let me start with introduction. So my name is Brooke McConnell. I have been head of education for Group 41 for about a year now. I'm still working as the head of education at FSV for a while. And I have been Group 3 student. And I'm also a graduate from AIT with a bachelor degree of electrical and computer engineering. Let's continue with you.
Okay. I'm Mukerem Ali. I am graduated from AS2 Adama in computer science and engineering, and my dual degree is also in electronics and communication engineering. My master's is I specialized on data science. Now I am a remote HSV from Group 48, and now I am working as a software engineer.
All right, thank you. If we are done with the introduction, let's get started with the most anticipated interview. I'm going to share a link for
Okay.
the share pad that you are going to be working on. And our interview is going to be 30 minutes. So try to be on time and try to use your time efficiently. Let me just share the link. Did you open the link? Oh, you have already shared your screen. Thank you. Open the link and check if you can edit the text.
Yes. Yeah.
Perfect. All right, now I'm going to copy the question for you.
Okay, can you give me an example?
Sure.
And the constraint also.
Okay. Here's the first example. And for a constraint, the maximum length of the boxes array and the warehouse array is going to be 10 to the power of 5. And each value in boxes and warehouse, it is in the range of 1 up to 10 to the power of 9.
Okay, the size is 10 to the power of 5?
The size is from 1 up to 10 to the power of 5, and the value is from 1 up to 10 to the power of 9.
Okay. Okay, the size of the box and the warehouse, it is equal, or is it different?
I think this is easier.
Okay. Okay, I have a question. I can insert multiple boxes in a one warehouse or in a one row.
No, the box cannot be stacked.
So every box should every warehouse should only insert only one boxes, or is it allowed more than?
No, it could only insert only one box.
So one warehouse contain only one boxes, right?
Yes, one warehouse could contain only one box.
Okay, the size of the box is greater than or warehouse, or less than the size of the box?
Maybe to further understand the problem, let me just show you a visual that
Okay.
will visually present the first example. Let me share my screen.
Okay.
Okay, is it visible?
Yes.
So these are the given boxes. The one on the left and the one on the right is our warehouse.
Okay.
So as you can see, one warehouse could only contain one box.
Okay.
And here at the bottom is the solution that gives the output of 4. That we can insert 4 boxes in this warehouse with this kind of setup.
Okay.
All right.
Okay, I have one question for the last paragraph.
Okay.
If the height of some room in the warehouse is less than the height of a box, what is that paragraph? I don't understand about.
Basically, you have two entry points into the warehouse, right? From the front or from the back. So if it is blocked, you can't push in some other box, basically.
Okay, but I can push from the other side.
Of course, if it is available from the other side, as you can see on the first example,
Okay.
You can push from the other side. Yeah.
Oh, okay.
Have you understood the question? Have you got the idea? Can I stop sharing my screen?
Yes.
All right.
Okay. The first approach is to find where we start, because we have like in warehouses. So the first thing is to find the index which we start the insertion. In every case, we can push from the left and from the right. But the first thing is to find the starting position of the warehouse. Okay, next. So we can use either the minimum or the maximum height from the warehouse to start. So which should be so we like start should be the index of the maximum height, because we can't insert any box that is higher than the maximum height of the warehouse. So we should start from that index. Then
I have a question.
okay.
What if, like, on the two sides of this maximum height warehouse, there are smaller heights, and they can't allow you basically to push the box into that specific place.
Can we insert a box by passing a lower warehouse?
Sorry, you are breaking up. What's that?
What?
You are breaking up. I didn't catch that.
Okay. Can I insert a box by passing a lower height of
No.
warehouse?
No.
It cannot.
Yes.
For example, the previous example. So how can the height 3 inserted? Because in the left and right side there are warehouses that has lower height than.
But in the left side, we have like the opening for the left side is the height of 3, right? We can insert a box with the height of 3. Maybe let me share the
Okay.
visual again. You got it?
Yes. Yeah. So first starting from 4. Okay.
Maybe let's skip the visual so it could help.
Okay. Okay. I can store the maximum inserted height for in each position when by using either from the left or from the right. For example, if I starting from the left in each index or in each warehouse, I should find the maximum height that can possible or to reach that warehouse. For example, I store the maximum possible height to insert in index I from left and right. So this is the first approach. So this is not work. So the first I should store the maximum possible height to insert in index I from the left and from the right. So I should first I find two different arrays that store the maximum height, which is like that. That is the first approach. Then, okay. So then the second part is I select the maximum from both arrays. We have two boxes, like left box and right box, or left array and right array. Left array, which stores the maximum height for each index, which is starting from the left, and the same for the right. So the second approach or the second step should be I select the maximum value or the maximum index which have a maximum value from both arrays. That is the maximum or the first inserted box or the first inserted warehouse. That is the first inserted warehouse. So, okay. The third is then find the box which is less than that value. That's less than that value and the nearest value. Find the box which have nearest height, and it should be value, for example, max height should be less than the value of max height. So first I inserted the first box, then I can use two pointers. I can use two pointers, which is Okay. And the first thing is yeah. In this case, it is monotonic. Monotonic means it's increasing array up to the highest peak value. Then it is decreasing, which means the array is like a v. It's like a peak value, which means starting from the left, it's increasing or either increasing or it's the same value with the previous up to some peak value. After that peak value, this value is decreasing or remains a constant. It's like a mountain value from the left and from the right. That is the array. So in this case, I should, yeah, 2 pointers like left and right. I have 2 pointers like left and right. So the left should be, this is the maximum height and it's the index. So the left should be index -1 and the right also should be the index +1. Then in each iteration, I select starting from the max. Yeah. So lastly, what is I should insert by using 2 pointers. Yeah, this is my approach.
Yeah. This makes sense.
And the given the box should be sorted also. So I sorted, yeah, the box because in order to use a 2 pointer, it should be sorted. Then after I get the maximum height, I decrement that value by 1. If it's not possible, I skip or continue to the next value.
I see. This makes sense. Are there any other points that you would like to consider? Anything that you have missed? Or do you think you're good to go?
So should I start?
If you are comfortable and if you're sure that your approach could work, feel free to start, since we have limited time.
Okay.
And I could copy the function structure for you, so it could be easier when we finally submit.
Okay.
Here you go.
Okay.
Okay, are you done with the implementation?
Yes, I finished. I'm testing. Okay, where is the function name?
We will do the testing part together.
Okay.
Like, can you maybe in 1 minute explain what you have done since you have been silent for a while?
Okay. The first thing is I create two arrays, which is the left and the right. The left, it's store the maximum height for each index, which I started the insertion from the left side, and the same way for the right side. It's the same operation, but it's the left and the right inserting direction. Then find the maximum height from both arrays, that's max of left and max of right. So then find the index value of that maximum. So I store in the IDX variable. So these both loops are searching the maximum value and the index. After that, the box is already sorted. I sort the box, then find the index value of that maximum box, because the other boxes that are higher than the given max box, they are not inserted in either way. So I should focus on the smallest boxes. So the first inserted index or the first inserted box should be, I find that index. So I use a bisect right because it is already sorted. So in bisect right, I can get the maximum box, and if I decrease by 1, I get the lowest or the smallest box. Then what I'm doing is I use left and L and R two pointers, which is used to insert from either direction. So the L is index -1. Index means the maximum value, and R is index +1. So there are three conditions. L should be positive, R should be less than N, and the index, this index iterates for the boxes. So what I doing, find the boxes at the given index. So the left array at the index L, that is the rightmost index when we inserted from the left. The rightmost from inserting from the left, if that value greater than or equal to V, that means we can insert that from the left side. So the count should be increased by 1, and the L should be decreased by 1. Otherwise, we can also check if from the right side, that is from the right side, the leftmost warehouse that can insert it. So that is the right value. Then we should also increase by 1 the R value, and the count also increase by 1. Always the index value, even if it's inserted or not inserted, that we can move to the next box. So we should decrease the box by 1. So finally, I return the count. Yeah.
Okay. All right. So since we have to check if this solution could work to solve this problem, we'll be going to the LeetCode account and we'll be submitting it. Since we're over on time as well, this is what we're going to do. Let me just share my screen.
Okay.
Okay. It's visible?
Yes.
Right. I have pasted your code. Let's try to run it. We're seeing wrong answer on the first test case.
Output 1 expected for.
This is unfortunate, but since we are, I think, 2 minutes past on time, we are going to be obligated to wrap up the interview here. Thank you so much, Mukerem. It was a great effort. Thank you so much.
Thank you.
All right, next up, we're going to move on to the next interview. And we're going to have 5 minutes break. So our YouTube watchers, take that break, maybe figure out the solution or what happened through the code of Mukerem. We'll be back in 5 minutes. Thank you. Hello, Brian. How are you?
I'm fine, bro. Salam. Hello.
I'm doing pretty well. I'm just starting the screen recording. So let's start. We are going to start with introduction, and we'll start our interview. So I think the recording has started. So let me start. My name is Brooke McConnell. I'm an interviewer today. I have been head of education for Group 41 for the past year, and I'm still head of education at USV. I have been part of the Group 3 at USV course, and I'm also a graduate from ISA University in Electrical and Computer Engineering. Thank you. Your turn.
Okay, I'm Birehan Antana, a fifth-year software engineering student at AIT, at Ababa Institute of Technology. I have been part of it in Group 43, and I have been part of it for almost completely a year. And yeah, that's all about me.
All right, thank you, Brian. Now I'm going to give you the link for the SharePad. Like go to the link and try if you can edit it, and I'll paste the question.
Yes, I can edit it.
Okay.
Okay, so give me a minute to read the question, and I'll be back to you.
Take your time.
So can I ask for an example?
Of course. Is there some sort of background noise? It's like disturbing.
No, it's the noises from the approach library, the your broadcasting. That's the noise.
Oh, we can't do anything about it?
I don't know what I can do about it. I don't know. Okay.
It's fine, just focus on your problem then.
Right. Yes. Okay, Brooke, are you with me?
Yes, Brush.
Okay, you will help me along the process. Let me tell you what I get from the question. So we're given two arrays, boxes and warehouse, right? And then representing, like, they represent the height of sandboxes of unit widths, which means the width is just one, meaning wise, and then the height of n rooms in a warehouse respectively, which means I have n rooms, and then the warehouse rooms are labeled from 0 to n-1 from left to right, and then warehouse at I is the height of the I's room, which means I have these four rooms, right? And then this each represent the height of that warehouse, right? And then moving forward, now what we can do is like that boxes are put into the warehouses by the following rules. So I have rules in here. So the first rule is going to be boxes cannot be stacked, right? And then another part is you can rearrange the insertion order of boxes. So what does that mean? Like I can, if I added some box into some warehouse, right? So I cannot stack it. I think that's the thing, right? So and then boxes are pushed into the warehouse from either sides, which is from left and from the right. So if the height of some room in the warehouse is less than the height of the box, what does that mean? Okay, so I have a height of some room in the warehouse, right? Let's say this is 3, right? And then that's less than the height of the box, which is the height of the box is the height of the warehouse is less than the box. Then that box and all other boxes behind it will be stopped before that room. Many-wise, they cannot enter in that room because they have because the warehouse has less height. So what do I want is a maximum number of boxes you can put into the warehouse. I think, is that the case?
Yes.
So let's try to see what the first example tried to see. So it's giving us an output of 4, and then we have a warehouse, which is I have 4 houses, and then I have these boxes, right? So let's try to insert into the first warehouse, which is a height of 3, right? So I can insert this, right? Because they have a less height. Am I on track?
But the question says you can't stack boxes, right?
Okay, so I can. Okay, my question is like, if on one warehouse, I can only insert one box, right?
Yes,
Is
yes.
that the case?
Yeah.
Okay, if that's the case, and then the warehouses are in some line, is that the case? Right?
Yeah.
There. So
Maybe to help you with understanding the problem more, I
okay,
could show you a visual, like
okay,
how these boxes are represented, basically.
okay, that's good.
Nice. Let me just share my screen.
Okay.
Okay. So as you can see, the boxes are here, and
Yes.
this is the warehouse.
Okay.
So
Okay.
I think the image is self-explanatory. You can insert the boxes in such a way. Yes. So you can insert a maximum of 4 boxes.
Okay. I see. I see. So okay. So at a maximum, I can have n boxes, which is the number of warehouses. At a maximum, that's the max possible number that I can have, I think. Now the question is much clearer. So let's get back to the problem. So I have 3. So it has to be okay first. So in here, like it's inserting 2 in here, I think, and it's inserting 3 in here, right? And on the next, it's inserting 1, and on the last point, it's inserting a 2, right?
Yeah.
So okay, so let me, if that's the example, I think we're clear on the process. Let me think of an approach, and I'll be
Okay.
back to you.
Sure.
So
I could just keep it on if you want to refer it at any time.
okay, now. Okay, so we are pushing the boxes into the warehouses based on the gap they're gonna have, because like in here I just pushed from the left these 2 warehouses, right? And then as much as I can push from the left or from the right. And in that gap, I went to push. Always, I want to push from the left or from the right. When does the minimum number? I want to push it into the best position it's gonna fit, and then the
Okay.
next. Okay, so let me process it. I think I have the perfect picture now. So, okay. So, can I ask for the limitation of the problem?
You mean the constraint, right?
Constraints, yes.
So the length of the box and the warehouse is from 1 up to a maximum of 10 to the power of 5. And
Okay.
the elements inside this array could range from 1 up to 10 to the power of 9.
Okay. Okay. So let's think it like this, right? So what's the brute force approach for this problem is going to be like, I have this number of boxes and I have this number of warehouses, right? So what I will try to do is like, I will sort the boxes initially, right? I will sort the boxes and I will try to push the minimum value, which is the minimum point of the boxes as far as I can from the left or from the right. So I have 2 branching in here. So I have 2 options, right? So meaning wise, I have sorted the boxes, right? And I have the warehouses. So I have 2 options to insert the minimum heights box. So I can insert it from the left or I can insert it from the right. Do I have any other solution for this? I don't think so, right? So because what? So in a brute force way, I will try to insert. This is 1 is the minimum. So I will try to insert it from the left. It can reach to this point, but it cannot surpass that point. And also I have this from the right side. So if I try to insert it, it's going to reach until this point. So it's going to branch into two ways. And then
Are we
moving
talking
forward,
about the first box, brother?
yes, I am inserting the
First
smallest
box.
eight. Yes, the smallest eight box and branching into
So
two ways.
yeah,
Whether to
like
insert
so
it.
you have said
Yes.
it's not going to surpass this point. What is that point that it can't surpass when you are inserting it from the left?
Meaning, like I have, let's say I have one box in here, right? So can I put one box in here?
Yes.
Yes. So can I put in here? Yes. Can I put it in here? It's also yes, I think, because I have a 4, a 3, a 4,
Yes.
and a 1, and a 2. Yes, it's possible. So, and also I can put it in here, right?
Yeah.
That's all the possibilities it can be put
Okay.
it into. So from the
Yeah.
left and also from the right. And
Yeah.
when 2 comes in here, let's say I put it in here or in here, but so I have a 2 in here, but what's the optimal way is going to be like, I have boxes and warehouses, right?
Okay.
So the minimum warehouse height is a reachable point from the leftmost and also from the rightmost, meaning if there is a box of height 1, it can be put it in all of them, but it's best optimal to put it in here, right? And moving forward, I have a next point ahead of 2, right? So what I'm really trying gonna do is like I will always take the smallest boxes and I will always take the smallest warehouses, right? And then I will push them as far as I can go from the left or from the right, which is like I'm gonna have 2 branching in such a way. But that's not gonna be a best way. And also I might have more than one choice. So what I'm gonna do is like, if it is a perfect fit, okay, that's good. Or if it's not a perfect fit, I'm gonna push it while I can, right? Meaning wise, if I have one in here, I can put it in here, right? Let's say I have another warehouses with, let's say, 2 in here, right? And then when I insert one in here, now I'm good. Now I have a 2 in here, right? So what's from the left, do I have a 2? Or from this, what's the smallest point that I have a 2, right? So this is going to be in here. So I'm going to put it in this part. So next move forward, it's a 2. It's going to be put it in here, right? And moving forward, I have a 3, right? I have a 3 and I have a 4. Now here comes a challenge. So I have a 3 and a 4. So if I put 3 in here first, right, it's going to cause a problem because like it's not going to be, I'm not going to be accessing 4 next to it. Because if I put 4 first, it's not going to surpass this point. So I'm going to put 3 in here. That works because that's the only way. And we're good to go, I think. So what we're gonna do is like, I don't have much of the time. So for each warehouses, I'm gonna pair them with their indexes. Meaning, for this, I'm gonna have a couple of, let's call it just where, and a couple of 3 with 0 index, and 4 with 1 index, and 1 with 2 index, and 2 with 3 index, right? So, and then I'm going to sort these values. So the smallest is going to be this one. It's going to come first, right? And this is going to come first. And I'm going to have something like this, right? And also I'm going to sort these positions. And then for one, what I'm trying to do is like, I'm going to have my range, which is like, now I have a left, which is, it can be feasible to put anywhere. So now in the first, I have 1 and 2. So it can be feasible. It's feasible. It can be put it into the first. So what I'm going to do is I'm going to have a 2 in here. And then afterwards, now I have a 2 box, right? So for 2 box, it's going to be put it into 3, which is the index. It's going to be put it into 3. And moving forward, I have, which is like 2, another 2. So it's going to be for 3, right? So, so while that 2 comes, right? I can put that into the inner side of the warehouse, right? So I will try to push it as far as I can, right, to the center. But in here, am I really doing that? Because like if I have a 2, right, but I want to push it until this 2 point, because I have another 3 which can be put it into here. Okay, so that's another scenario. Okay.
So
So
maybe okay. You want to
so
continue?
okay, I'm missing something because like
Yeah, I was about to give you a counter example. What if I add 2 here? Are you going to
actually
be able to insert 4? Like the box with the height of 4? Are you going to be able to insert this box?
no, I can't insert it for.
Why?
Can't insert
Why?
it because there is no way to insert it between this and this. So it's not gonna
What?
surpass the left and the right point. So it's not feasible. Okay,
Just
okay,
to make
that's
sure, just to make sure. Because on
yes,
your approach, it looks like you are not considering that. That's why.
yes. Actually, it makes perfect sense. Okay, let's try to see it in another dimension, right? So a box come in here, right? The smallest box, and then I'm gonna push it while it's the closest point that I can get out of it, right? That's okay. If this is 1, I can push it until this point, which is the smallest close height that it can get, right? So that's the point. So moving forward, I have a 2. So can I push it from the left? Yes, I can push it to this point, or I can push it from the right to this point. But what's a better way for me, right? So what's a better way for me is like to push it until this point. And then I have another 2. So what's better now? To push it in here or to push it in here? So it's gonna be this one. So every time it's gonna okay. So okay, I'm stuck a little bit. So
Maybe try to
can
see it from, like as you have said, from a different dimension. Because if you think about it, like the setup of the warehouses matter, right?
yes,
And as we have said earlier, even though you have something like if even though you have a warehouse with the height of 4, you can't insert a box with the height of 4 because you have to push from either side. So
yes,
somehow the sides are kind of determining what goes in or like what could be
what
inserted
goes
in
in?
this warehouse.
Yes, it makes
Does that make
perfect.
sense?
Yes, it makes sense. So
So like try to use this informations, try to come up with like a different approach maybe.
okay. So okay, so what I was thinking is, let's pre-process what values can I insert from the left or from the right. Okay, so we have a warehouse of 3, 4, 1, 2, right? So from the left, what's the maximum value that I can insert? So let's have a left, and I can insert a height box with 3 at a maximum. So moving forward, I have a 4, which is greater than, which is the before one. So what's the maximum value that I insert until that index? It's going to be 3, right? And then moving forward, I have a 1, right? So what's the maximum height I can insert from the left until that point? It's just only 1. And for 2, from the left, I can only insert 1. And from the right, I'm going to do the reverse of this operation, right? So I'm going to have a 2 in here. So I'm going to have height of 2 at the maximum on the last part. And afterwards, I'm going to have a height maximum of 1, and then 1, and then 1. This is the values that I can insert from the left. If from the left I can insert such a way, and from the right I can insert in such a way, right? So what I have is I have boxes in here, right? So I have 1, 2, 2, 3, 4, 5, right? So what I will try to do is like, so I have 3 in here, good. So I have 1 in here. So I have to mix some of them in such a way to get the maximum value. So let's say mix it. So I can have a maximum of 3 in here, 3 in here, 1 in here, 2 in here. Yes? So these are the values that achievably inserted, right? So meaning wise, I have 3, 3, 1, 2. If I have 3, 3, 1, 2, like what are the pointers that I can insert in this range? So I have meaning wise, I have 1, 2, 3, 3, which means any value which is less than or equal to this can be inserted. Yes? Am I clear?
Yes, you are.
So if that's the case, I have 1, 2, 2, 3, 4. So if that's like, and then I'm going to use like, I have 1. So any value less than 1 can be inserted into the minimum position, and 2 in here, and 3 in one of these 2, 3, 2, and then I can insert these 4 values. Am I clear? Am I on the right track? Should I proceed to the implementation? So this is of n time.
So it makes sense for me so far.
So can you give me the base function, or should I write it up?
Right, if you're comfortable and ready,
Yeah.
I could give you the structure of the function.
So let's have left in here, right? So for in range, line of warehouses. So the first value is going to be itself, right? So warehouses, an index of 0, right? So what I want to try to do is from the first one, and so it's going to be left dot append. I'm always taking the minimum, so that's going to be warehouses at an index of I, comma, left at an index of left at an index of -1. So this is moving forward, and let's do the reverse. So I'm going to have a right. So it's going to be at -1. So this is going to range from len of -2, -1, -1. And okay, this should be something like this. I cannot append into it, so what's a better way is to initiate it with 0 times length of warehouses, and right, an index of -1 is going to be something like warehouses, an index of -1. So moving forward, what I'm going to do is like left, this is right, so it's going to be I plus 1. So right, at an index of I is going to be minimum of warehouses, and then that's going to happen. And afterwards, so the max height that I can insert into them. So it's going to be like a list of maximum of left at I, comma, right at I, for I in range, len of, let's say left, right? So this is the max height that I can until that point. So I have the boxes, so I'm gonna sort the boxes, dot sort, right? And that's the max the max height that I can insert. So this can also be sorted. So what I will try to do is like, so initially I have, let's say I have 1, 2, 3, 3, and 1, 2, 2, 3. So for each boxes, I will try to, so max inserted, initially it's going to be 0, and so for I in range minimum of line of boxes, or line of this max height, right? So that's the maximum point that I can traverse. So for that, for each of them, like I will try to put the minimum into it, right? So if there is no way to put that into to put the ball into that warehouse, it's not going to be feasible. So I'm going to return at that point. So 1, 2, 2, 3, 4, and 1, 2, 3, 3. So if boxes at I less or equal to max 8 at I, I'm gonna max inserted, max it's gonna be plus equals 1, and else I'm gonna break and I'm gonna return max inserted. So let's try to go over it. Am I on the right track, the approach, or I missed?
Yes, like your idea makes sense. We have like 1 more minute. I'm going to give you 30 seconds, like to fastly like run on your code, and we have to try it. Yeah, we don't have
Okay,
time.
so let me please run over it, and then we can move to the next part. Okay, so I start from the left, and then from the first warehouse, I'm gonna append with to the left, which is the last element of the left and minimum of now, right? And then I have all of the warehouses, and then from the right, I will try to do like something like this. Okay, lane of warehouses, and -1 is gonna be warehouse at -1. Okay, -2, right is gonna be something like this. Okay, so I don't need these prices. So warehouse at I, all right, +1, right? So that minimum is gonna be put it, and max 8 is gonna be max of left I, right I for I in range lane of left. So I sorted both of them, and if boxes at I, which means the box that I can insert is less than or equal to the max 8, it's gonna keep proceeding until the last point. Okay, if the boxes are 4, okay, initially it was 1, 2, 3, 4, 0, 0. It's
Brush, we don't have time. Like, we're gonna have to move on to testing your code.
okay.
All right. I have copied it. Let me share my tab. Is it visible?
Okay.
Right. So this is your code. Let's try to run it. Okay. It passed the first test case.
Okay.
Let's try to submit it. It's giving us a wrong answer. But it was a decent effort. It was you have done all you can. Thank you, Brush. We will let you know about the results in a few minutes. Thank you.
Okay.